So far we've looked at lots and lots of linear relationships, but not all relationships are linear, not all functions are linear. So in this section we're going to take a look at some functions that are not linear and how we can tell the difference between linear functions and nonlinear functions. Now this one, it says graph the data in the table and determine if it's linear or nonlinear. So remember x-axis down here, y-axis over here. Looks like we've got to get 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. And so we have the first point 0, 6, which is up here, and then our next point 1, 4, which is here, and then our next point 2, 2, which is here, and our final point 0 or 3, 0, which is here. And if we look at that, that's very clearly a line. It has a slope of -2, it's got a y-intercept of 6, so we could write y equals -2x plus 6. It is a line. If we graph these points, so x is 1, 2, 3, but y is going all the way up to 12. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our first point, x is 0, y is 3. Our next point, x is 1, y is 5. Our next point, x is 2, y is 8, 2, 8. Our next point, x is 3, y is 12. It's all the way up here. And if we connect these points up, we can see that that's actually not a line. Like between here and here it has a slope of about 2, but between here and here it's got a slope of about 3, and between here and here it's got a slope of about 4. It's constantly changing slope, so non-linear. And all that means is the points don't lie in a line. They don't have a constant slope. Now, we don't actually have to graph in order to see that. For instance, take a look at this one. X is changing. When x goes up, it went up by +3. And then it went from 6 to 9, it went up by +3. Then it went from 9 to 12, we added 3 to get there. What did y do? Y went from 40 to 32. That's -8. And then went from 32 to 24. That's -8. And then went from 24 to 16. That's -8. So this tells me whenever x changes by 3, goes up by 3, y goes down by 8. In fact, that actually tells me a slope. The slope is the change in y, -8, over the change in x, +3. And so I actually have a slope. These points are linear. We could graph them, they would lie in a line. Here, our x is going up by 2, and then it goes up by 2 again, and then it goes up by 2 again. Our y went up by 9, but then it went up by 22, and then it went up by 55. Those are not constant, right? So I can't write a slope this time because I can't say x goes up by 9 when y goes up by 9 when x goes up by 2. It did once, but the next time it was 22 over 2, and the next time it was 55 over 2. Our slope didn't stay constant, so this is non-linear. The easiest ones to recognize are, of course, graphs, because they drew the picture for us. It says, does the graph represent a linear or non-linear function? Well, a linear function clearly has all of the points in a line, and so we get a line. This is a curve. It's not a line, so non-linear. Linear. Right? So if you actually have the graph, that's the easiest ones to tell. Equations are a little bit trickier, but you guys know what a linear equation looks like. And a linear equation looks like y equals mx plus b, or it can be rewritten in that form. So for instance, a is equal, that can be written as y equals 0x plus 4.7. So it's a horizontal line, it's got a 0 slope, and it's at 4.7. So it's a line. Y equals pi x. We can write this as y equals pi x plus 0. So it is a line that goes through the origin, has a slope of pi. We can write it like that. Y equals 4 times 1 over x plus 0. This is not x, it's 1 over x. This is non-linear. We can't write it in the y equals mx plus b form. Here we have y equals, we're going to distribute that 4x minus 4. That's y equals mx plus b. It goes to the point 0, -4, and has a slope of 4, so this is linear. So the only one on here that's non-linear is c. And essentially, with an equation, if your x is in the denominator, if you have y equals and you have some number a over x, you know it's nonlinear. And if you have y equals some number a whatever times x to a power, anything other than 1, so if this is 2 or 3 or 4 or whatever, then again nonlinear. So in order for it to be a line, you have to be able to write it in y equals mx plus b form. Let's do one more example. Y equals x plus 5. Well, that's clearly 1x plus 5. That's a linear equation. Y equals 4 over 3, or 4x over 3. We can write this as y equals 4 over 3 times x plus 0. That's linear. And then we have y equals 1 minus x squared. That's a power of x. Non-linear.